Myself Lavan. Today's our topic is ionization energy. The minimum energy required to remove an electron from isolated neutral gaseous state of an atom is known as ionization energy. The units of ionization energy are electron volt. 1 electron volt equals to 1.602 into 10 power minus 19 joules, and that is equals to 1 electron volt equals to 23.09 kilocalories per mole. The order of ionization energy is IE3 is greater than IE2 and IE2 is greater than IE1. The factors which is affecting ionization energy are atomic radius, nuclear charge or nuclear power, screening effect, penetrating power, electronic configuration. Atomic radius is inversely proportional to ionization energy. When atomic radius increases, ionization energy decreases. When atomic radius decreases, ionization energy increases. And nuclear charge or nuclear power. When nuclear charge increases, ionization energy decreases. When nuclear charge decreases, ionization energy increases. Screening effect is inversely proportional to ionization energy. When screening effect increases, ionization energy decreases. When screening effect decreases, ionization energy increases. Penetrating power is directly proportional to ionization energy. When penetrating power increases, ionization energy increases. When penetrating power decreases, ionization energy decreases. Electronic configuration is directly proportional to ionization energy. In electronic configuration is divided into three types. One is incompletely filled electronic configuration, half-filled electronic configuration, and full-filled electronic configuration. In this half-filled and full-filled electronic configuration are stable electronic configuration. Variation of ionization energy in groups and periods. In groups, top to bottom, ionization energy increases because atomic size decreases and nuclear charge increases. In periods, left to right, ionization energy increases because atomic size decreases and nuclear charge increases. Thank you for giving an opportunity to me.